Hello everyone, welcome to ExamRat. My name is Shatabdi, I'm a second year medical student. So our topic for discussion today is some sums related to the topic current. So let's get started. Our first question here is that how much energy is given to each coulomb of charge passing through a 6-volt battery? Okay, so what we have here is the potential difference between the circuit. So we know that V equals to W by Q, or Q or W equals to V into Q, and we know Q equals to NE. So this is not required for now. For now, what we have to understand is that W is here referred to as the energy that is given to each coulomb of charge, and you know that work done is also can also be like energy is like the extent of doing work. So in the same way, we can correlate energy with work here. So 6 volt into here Q is the coulomb, right? Or 1 coulomb rather. So it is nothing but just 6 joule. Very simple. Okay. Let the resistance of an electrical component remain constant while the potential difference across the two ends of the component decreases to half of its former value. What will be the current through it? Okay, so we know V equals to IR, or I equals to V by R. Here we are keeping the resistance constant, so we know I is directly proportional to V, right? So here, if the potential difference across the two ends decreases to half its former value, what will be the change? So VF is equals to half V, right? So we have to find IF. So what we usually had done in our previous classes is that we just take a ratio. So VF by V equals to IF by I, right? Like keeping the potential difference keeping the resistance constant, we can divide the potential differences and the currents. So VF is half V divided by V, IF by I. So IF is equals to I by 2. So the current passing through the potential difference now is half the current that it used to flow. So why? That is very simple, because you know that V is directly proportional to I. So the graph is something like this, right? And it will increase proportionally. So the amount you increase the voltage, the equal amount the current will flow through that conductor. Okay, draw a schematic diagram of a circuit consisting of a battery of 3 cells which have 2 volt each, a 5 ohm resistor and an 8 ohm resistor and a 12 ohm resistor. Okay, so connected all in series. This is the keyword here, and there are battery of 3 cells. So if there are connected a battery of 3 cells of 2 volt each, what will be the total potential difference or the electrical potential of the whole circuit? It will be 2 plus 2 plus 2, 6 volt, right? Okay. Now we know that 3 resistors are connected. So, sorry, resistance, not bulb. So 1, 2. You can place them however you want. Like I'm doing it like this. So we got the voltage, we got the resistances 5, 8 and 12, and a plug key. Okay, so we have to also draw a plug key here. So let's just draw it here. You can draw it like this. You can also have drawn it like this. Anything is fine. Okay. So even if the question here has said just draw it, so we'll just, for the sake of it, calculate the resistance, total resistance here. So it is 5 plus 8 plus 12, right? 25 ohm. Okay. So now I hope it is clear. Like, since they are connected in series, so we just find the total resistances by just simply adding the individual resistances. That was what we had learned in the previous class. In case you have missed our previous class, you can just go and see it on our YouTube channel. Okay. So we can also calculate the current flowing through each of the resistances here. It will be all the same. We knew it. So V equals to IRS, or I equals to V by RS. V here is 6 volt, R here is 25. Okay. So let's just keep it fraction for now. Or if you want, we can just convert it to 0.24 ampere. Okay. Redraw the circuit of question 3, putting an ammeter to measure the current through the resistors and a voltmeter to measure the potential difference across the 12 ohm resistor. Okay. So we draw the circuit again. This time we will draw an ammeter as well. What is the use of an ammeter? It helps us measure the current which is flowing through the circuit. And also here is the third resistance. Okay. Here is our key. Also, we have to put a voltmeter against the 12 ohm resistance, right? So we know that since all of them have different values of resistance, their voltage will also be different, right? Because we knew that V equals to V1 plus V2 plus V3 when we talked about the series connection. So we have to basically find the potential difference between these particular 2 points, or the point across which the 12 ohm resistance is connected. Okay. But ammeter, we know that all the current flowing through all of these resistors will be the same, and so will it be through the metallic wire. So ammeter can be placed anywhere to calculate the current. Okay. So we had calculated the total resistance, right? It came to 25 ohm, and we also calculated the current also. So we don't have to do it here again. Just write I equals to 0.24 ampere, and we know voltage is 6 volt, and also that the total resistance is 25 ohm. Okay. So now we know that as the first part of our question, the ammeter measures the current of 0.24 ampere. Achha. And now the interesting part is that the potential difference across the 12 ohm resistor. So now what do we know? V12, rather, if I write, equals to I into R, right? Here, what is R? If this is 1, 2 and 3, and I give it as R3, or I'll just write 12 for better understanding. Since the resistance is 12 ohm. So V12 is basically 0.24 into 12, right? So this will come to something of 2.88 volt. Okay. So the voltmeter measures a voltage of 2.88 volt. Okay. An electric lamp of 100 ohm, a toaster of 50 ohm, and a water filter of resistance 500 ohm are connected in parallel. to a 220 volt source. What is the resistance of an electric iron connected to the same source that takes as much current as all the three appliances, and what is the current through it? Okay, so let's just draw it first. Let's just first draw a source. This is the 220 volt source. Now we are going to draw the circuits or the resistances. So 1, 2, 3, and for the fourth one, or the electrical iron one, I'll draw it with just a different color. Draw it here. So what we can understand here is all of them are from the same potential difference. So if this drawing is confusing for you, you can just draw it like this. And I'll just draw with a separate color. And we have to automatically assume that this is the 220 volt. Okay. So 100 ohm, 50 ohm, 500 ohm, right? So first we have to calculate all the total parallel resistance. So how do we do that? Okay, yeah. So 1 by, I'll just directly write the 1 by 100. Okay. So we do it like we used to do it LCM wise. So 10 plus 1 plus 5, which is 16 by 500, or Rp equals to 500 by 16 ohm. Let's just keep it in fraction for now. So we have found the total parallel resistance. So now I think we can calculate the current flowing through all the resistances together. So that is V equals to I Rp, or I equals to V by Rp. V is 220 and Rp is 500 into 16. Okay, so this will come to somewhat so 352 divided by 50, 35.2 divided by 5, something around 7.04. 7.04 ampere. Okay, so we found the current flowing through all the three resistance together. So now the second part of the question is that what is the resistance of the electric iron connected to the same source that takes as much current as all the three appliances, and what is the current through it? So now we know what is the current through it, right? Because see, it's the second part of the question. It wasn't like in the same question that the fourth appliance was connected. It's a separate part, like we have calculated the three. Now they are saying that, for example, if I attach another resistance to the same source that takes as much current as all the three appliances, then what is the resistance and what is the current through it? So we've already found out the current. They have said that the current through the fourth resistance will be the same as all the three combined. That means if all the three have 7.4 ampere together, then this resistance alone will take a current of 7.04 ampere. Okay. So in that case, now our calculation becomes very easy because we just have to find the resistance, which is V by I, right, equals to R nu. So this is coming to, just do it here, Rn is 220 divided by, if we just take the fraction of here, then it was 220 into 500 by 16, right? So you can understand now what it's saying here. It's that this resistance is the same as the total parallel resistance that we had found out, right? So obviously it will be the same because the same amount of current is flowing and the same potential difference. So obviously the resistance will be the same as the cumulative resistance of all the three in the parallel circuit. So Rn is nothing but the total amount of parallel resistance that we had found out. Okay. A piece of parallel resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R prime, then the ratio is what? Okay. This is an interesting question. First, they are saying that a wire they have cut into 5 equal parts. Okay. So we knew R equals to rho L by A, or R is directly proportional to L if these two are kept constant. So in that way, if I have divided the length by 5, then the resistance also gets divided by 5. Okay. So now each piece has a resistance of R by 5. In such a case, if you then connect it to parallel, what will it be? It will be something like this, right? 1, 2, 3, 4, 5. And all of them have R by 5 resistance. Okay. So Rp is 1 by R1 plus 1 by R2 ऐसे करके 1 by R5. Okay. Or Rp is 1 by R by 5 plus 1 by R by 5 as we do it. So this can also be written as 1 by Rp equals to 5 by R plus 5 by R again. I'm taking the 5 is common. So, or I'll just multiply the whole thing by 5, right? So 1 by Rp equals to 5 into 5 by R. Okay. Yeah. So what we are getting is 25 by R. Okay. So Rp equals to R by 25. So now this they have asked us to write as R prime. So R prime equals to R by 25. So now if we calculate the ratio, or R prime is basically R by 25, or the newer ratio is basically 1 by 25 times of the initial ratio. So what does this mean? This basically means that, okay, so to our answer, for our answer it will be this one, D. But what it means is that obviously when you connect any any resistance in the parallel combination, their sum of or the cumulative resistance will always be very low as compared to if it was connected in series, right? So this is what you have to understand, that always every electrical appliance should be connected in parallel to the circuit so that least amount of resistance is given to the flow of current. An electric bulb is rated to 20 volt and 100 watt. When it is operated in 110 volt, the power consumed will be, okay. So we know that P equals to V square by R, or 100 equals to 220 into 220 by R. Here we find the R through the R resistance of the electric bulb. So this is right. Just checking, sorry. Sorry, 484. Yeah. So 484. Okay. So now, when you are operating the electric bulb at 110 volts, so only the power source, only the voltage source has changed. What remains same is the resistance, right? So now, just draw it with a different color. So P equals to now V square by R. Only now V square is 110 and R is your 484. So what do we get here? Again, so 100 by 4, so 25 to 25 watt. Okay, so this was when we calculated the whole thing, but in most competitive exams you won't have the time to calculate, right? So what you have to remember is the direct relation between power and voltage. So power is directly proportional to the square of voltage. So here you have decreased the voltage by half. So how much will the power be decreased? It will obviously be decreased by 4 times, right? That is what happened, that initially it was 100 volt and then it came to 100 watt and then it came to 25 watt. That means that power was exactly divided by the 4. It became 1/4. So this you have to remember, that instead of going through so much of calculation, you just directly have to remember this equation and imply it. So that will be it for the current chapter. In our next session, we will start with magnetism. Thank you.